As you can see, it's making the clicking sound again. This PCB has sparked at this point here, so let's see whether this PCB is repairable or not. In this PCB, first of all, we have to check the low side. We will check the high side later, because the high side in this PCB is repairable. But if it's microcontroller and its low side are out of order or short-circuited, then it is not repairable. Sometimes there is a chance that the PCB cannot be repaired. So for this, we will put the meter into continuity mode and check it in continuity mode. So here we have these capacitors installed: C18, C29, C89, and C105. We have to check these. And as you can see, this capacitor is short, the second one is also short, and the next one is also short. So when this kind of situation happens, these capacitors become grounded. The positive and negative join together. Then the microcontroller gets shorted and develops an issue. In that case, this microcontroller has to be changed directly. We do not have any other option. Now let's move to its high side. First of all, on the high side, we have to check the IPM whether it is okay or not. We will check it in diode mode. So I have connected the probe positive to positive and negative to negative, and it will tell us everything. It looks fine. Yes, it seems okay. Now we will change the probes. Positive probe on negative and negative probe on positive. And as you can see, the voltage drop will build and then stop. Now I will check on W. So this is fine. Next V is also fine. Next U is also fine. So this means there are chances that the IPM is okay, because when the system runs, then it becomes more clear and confirmed. Now we will check the IGBT. No matter where I place the probes, as you can see, 0.230 volts are coming. This voltage drop is a little risky. Such a low voltage drop should not come. I think our IGBT is short, but we will have to see what is causing it. It looks faulty to me, and this diode is okay. It looks fine. Now I will check the bridge rectifier. So we put negative on positive and positive on negative and check it. It looks fine. Move ahead. This one is also fine. So the fault seems to be in the IGBT, while the other things are looking okay. When there is no problem in the IPM of this PCB, then these capacitors also usually do not create problems. But it is very important to check them once. We will check them in continuity mode and see whether ground is mixed or not. So no, these are fine. The next ones are also fine, and the next ones are fine too. All of them are okay. This means there is no issue here. Now, because of the short circuit in this relay, this microcontroller has become shorted. Now I will directly replace it from here, so I hope the whole system will become okay. But before changing it, we will check this burned point to see whether there is any other issue here or not. Now this short circuit has happened near this relay. As you can see, this high side and low side, I think they got attached together. Look here, I think there is some water or some kind of work has happened here. So this relay here belongs to the low side, where low voltage comes, and this point here is coming from the high capacitor. As you can see, capacitors are installed here, both of them. So from here, it is directly connected to this point. So the high and low got mixed together, and after that, maybe a short circuit happened, because of which this problem occurred. Now, up to this point, I have not done any work on it yet, so I will check these capacitors again. I will put the meter into continuity mode and check them. They are completely fine. And as you can see, so far I have only changed the microcontroller in it, and all the short circuits have disappeared from it. Look, the multimeter is fine now, and there's no sound coming here anymore. And in the same way, this ZD7 diode installed here was also showing a short circuit before, so now I will check it as well, but I will check it in diode mode. As you can see, it is now showing a proper voltage drop. When I reverse the polarity, it is showing a 0.439 voltage drop, which means the system is now okay. And in the same way, we will also check this IGBT here, because it was not showing its proper value before. So now I will check it again, and it will also be checked in diode mode. As you can see, it is showing the same value everywhere, which means this IGBT is faulty. I will test the IGBT here, because by testing it, I will know whether only this component is faulty and nothing else is damaged. So as you can see, it is still showing the same value on all 3 pins, which means this one is faulty. By testing it, we can tell that there is no other faulty component in the PCB. In the same way, without the IGBT installed, we will check its IGBT drive circuit to make sure there is no issue in it. Because if even one component in this section becomes faulty, then the IGBT will keep getting damaged, or the microcontroller will start malfunctioning. So let's check it. Here we have a diode reading. The next one is also giving a diode reading. Then we have these important transistors installed here, NPN and PNP types, so I will check all 3 one by one. 2 are fine. Now let's check the last one. This one also looks fine. Yes, this one is okay too. So all the readings are fine. In the same way, this diode installed here, let's check it as well. It is also showing a proper reading. Now lastly, there is one more diode installed here. Let's check that too. There is a chance that it is fine, but still let's also check it once in resistance mode. Yes, this one is fine, and the next one is also fine. So everything is okay. There is nothing damaged here. Now in the same position, we will check the IGBT. As you can see, it is now showing proper voltage drop perfectly. Now we will change the sides of the probes. And yes, it has become completely fine. The proper reading has now started appearing on it. Now we will test this relay to see whether this relay is okay or not. So first what we will do is attach alligator clips on top of it. As you can see, we have connected them on both sides. Now it is okay. After that, we will take a normal 9-volt battery that we have available. We will connect one point into it. Look, I have connected it now. And you can hear the beep sound coming from it. When I remove the connection, the sound stops, which means the relay is okay. Now I will reinstall. I have powered it on, but something has gone wrong here. As soon as I picked up the PCB, this area turned black. And look here. It has become black again. This is not right. It should not happen like this. So let's find out why this happened. I think some point might be touching somewhere, but there doesn't seem to be anything like that here. Then why did it turn black? And it became black from this area here. Maybe something fell onto it. Let's remove it once again and inspect it properly. And this is really bad. I have removed it now. Look, there is nothing underneath it either. Everything is completely fine. And here as well, there is nothing unusual. Now, let me explain what is actually happening here and why this problem is occurring. As soon as I replaced the microcontroller on this PCB, it started showing the same problem that we had already seen in one of our previous videos. At that time, there was a very loud clicking sound coming from these relays, including this relay as well. Now, after installing it again, the same problem has returned. So let me show you what I have done here. I removed its Darlington array, and along with it, there were 4 resistors installed here, each rated at 10 kiloohms, and the area that burned just now actually burned because of these resistors. These resistors had already been badly burned. Due to that, the voltage started fluctuating up and down, which caused the issue. These resistors are now completely burned out. Because of this, there is still a chance that our microcontroller survived. Otherwise, we may have to replace the microcontroller once again. So let's check whether we were lucky or not. I had removed these relays earlier because they were making a very loud clicking noise. I had also shown this in a previous video. The sound was extremely loud and would not stop at all. That's why I worked on this PCB for a long time, so the actual fault could finally be traced properly. So I removed those resistors. Now I wanted to show you that this relay and this relay were making noise. But at the moment I had removed its Darlington array and the resistors as well. Because of that, a slight issue appeared in the board. But I hope this problem will not happen again next time. Now, regarding this clicking sound, I had already shown it to you earlier in the video. We are going to solve it, because fixing this issue is extremely important. Only after solving it will this PCB work properly. Otherwise, even if the microcontroller is fine, this PCB will still be useless. So for this, I will repeat the same procedure again, but I will not make a separate video for it. I'll just explain it to you briefly. The good thing is that our microcontroller is safe. There's no issue with it. Now I will install everything again, and then I'll show you how we are going to fix this clicking sound problem. Now the clicking sound has started again. So look at this. As you can see, the switching sound has started again. The relay is switching repeatedly, which is not normal. What I have done here is disconnect the power supply. As long as the capacitor remains charged, the sound will keep coming from the PCB. Now the clicking sound has finally stopped, and this PCB is completely repaired. This is the same PCB that we worked on earlier in the video, where the sound problem was not going away. And there are 2 more PCBs here as well. I had a total of 3 PCBs, and all 3 had exactly the same issue. But now, as you can see, all 3 of them have been repaired successfully. Now look here. I'm going to start it by supplying power. I have powered it on, and the outdoor unit lights labeled 1, 2, and 3 have turned on. And all 3 lights have shut off now, which is completely normal. There is no sound coming from it anymore. Previously there was noise, but now there is absolutely no sound. Now here, I have connected the second PCB as well. And look, I have removed this one because it is now completely okay. Along with that, we are also going to run the compressor. As you can see, I have installed the heatsink on top of it. Now, I'm supplying power to it again. I have powered it on, the indicator lights turned on, and then switched off normally. Look here. The fan motor also turned off properly. In the same way, the outdoor fan motor relay has turned on, and the compressor has also started successfully. Its speed is slow right now, but slowly it will become faster. We will not run it for too long, because the IGBT and related parts here are still exposed, and they should also be mounted on a heatsink, otherwise they can get damaged. So for this reason, I will turn it off now, and later we will run it again properly with the heatsink installed. Now let me explain what the issue was in this PCB. What was happening is that when I repaired the PCB, after repairing it, I was testing it without connecting it to the indoor unit. And since I had changed the microcontroller in it, I think its programming is designed in such a way that until it is connected with the indoor unit, it will not function properly. Otherwise, it goes into a floating position, meaning it becomes confused, and that is why it keeps rotating continuously. It starts behaving strangely, like it doesn't know what to do. So, as soon as I connected it with the indoor unit, the PCB became completely fine. In the same way, this second PCB also became fine. And this third PCB is also working perfectly now.
Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.